tells you how much during the training, how much of it is used for exploration, and there's like learning rate. So I basically put like all the different values that were like general like used values, and I cycled through them and cycled through different configurations to find which one was the best, and I basically implemented that.
Okay, awesome. Yeah, that sounds super cool.
All right, and I have another question. Are there any other customizations that you're interested in implementing or would like to implement?
Yeah, I think I would like to implement like maybe different like AI agents because in this one I used a DQN network, DQ network. I was exploring like different other like models I could use for this project, and I came across a few others like a PPO model, and I think it would be really interesting to see how a different model would like perform.
All right. Thank you, Siddharth. Congratulations on a great project, and I'll turn it back over to Josh.
Thank you. All right. The next student that we have is Roger. Unfortunately, he wasn't able to make it today because he is such an overachiever. He's actually at another camp right now, attending a mandatory guest speaker, unfortunately. However, he did record a very nice video and demonstration for us that we will have the opportunity to watch. Now, Roger pursued an audio-based electrical engineering project, which is really similar to the kind of studying that I pursue at my university. And I believe that Roger was able to integrate his two passions of both music and engineering into a project that he just always wanted to continue and always wanted to add new features to, which was extremely admirable. So, uh, I now present Roger. All right.
Name is Roger. I go to Wilcox High School and I'm going to my senior year in high
Can you guys
school.
hear?
I did the button piano for my project. I'm now gonna demo my project. One challenging aspect of my project was figuring out how to play multiple frequencies. I found out that my Arduino Uno, which is the brains of my project, only allows for 3 frequencies to be played with just the buttons alone. However, I'm actually only able to produce 1 frequency with the buttons. This is because I installed a DF player, which mitigates around the 3 maximum frequency limit. Now, since I can play MP3 files, it means I can play more than 3 frequencies, which is one challenging aspect I was able to get around. Lesson and experience that I gained was that I had to keep trying and trying over again. Because if I have never tried and failed so many times, then I never would have gone to the end goal of my project. And this is one of the reasons why I joined Bluestamp Engineering, because I wanted to have an actual engineering experience with actual engineers that could help me. And thinking like an engineer was something I've always wanted to do. And I myself am a pianist, which is why I wanted to start with the button piano as my main project. Thank you.
So, that was Roger's presentation. Even though he wasn't here, he still gave an awesome demonstration of this project that I think is worthy of praise. Does anyone have any questions that I can answer on behalf of Daniel? Okay, well, if there are no questions, I'll hand the presentation back over to Julia. Thank you.
All right. Our next presenter is going to be Noah. He did the Smart Mirror project and also finished within a few days and ended up being able to do a lot of really awesome customizations, ranging from a Spotify module to Google Home integration to having multiple pages on his mirror and even having a reflective film to integrate a mirror functionality with all of his modules. So I'll turn it over to Noah so that he can tell you more about it.
All right, hi, my name is Noah, and I'm an incoming sophomore at Murrow Catholic. And this is my Magic Mirror project. So I'll just go over the base project first. So here's the base modules, which is the time, calendar, and date, the complement message, the news message or the news headlines, and the weather and forecast. So I customized two of these modules by changing the news to cycle between the NBC Bay Area News and the New York Times, and I changed the weather and forecast to my location instead of the default New York location. So as you can see, there's also the Spotify module, which displays the Spotify information you're listening to on your account. So it'll show the album cover and name and artist. And then I also added this NHL kind of like leaderboard thing, which just shows games that are going on right now. So as you heard, there was I added a Google Home integration. So basically, I can like say I'll do a demonstration. So hey Google, turn off my monitor power, and then it just turns off. And I can also do, hey Google, turn on monitor power, and then it'll turn back on. And then another command I added was, hey Google, turn on page 2, and it'll switch pages. And where I added another module, which was my Google Calendar. So here you can see the different events. So you could just put it on your regular Google Calendar and it'll show. So yeah, and then one thing I struggled on a lot was my Google Home integration. So I had to go through like many different ways of doing it before I found an actual like good and working one, which I ended up doing Home Assistant. So I used Home Assistant, which is basically you can just like think of it as an add-on to the Pi. You could just download it on it, and then I used that's for the commands, and then I used Nabu Casa to actually link the like Raspberry Pi to my Google Home itself. And then also the hardware is just a monitor connected to a Raspberry Pi, and then the reflective film on top. So lessons I learned and experiences I gained was I obviously learned how to um, work with the Pi, and I learned a lot of software stuff such as the coding and working with the Pi environment. And like one thing was SSHing from VS Code. And then one big thing I learned a lot was like researching skills because I had to do a bunch of that for all the modules and stuff like the Google Home integration, also stuff like that. And so why I chose this project, it just seemed the most practical, like getting out of bed and just looking at all the useful modules and even fun modules too. And then I joined Bluestamp Engineering because I wanted to get some hands-on experience with engineering. Or actually, not just hands-on. I also wanted to get some coding experience too.
Awesome. Thank you, Noah. And does anyone have any questions for Noah?
If you had more time to add other modules, what would you add?
I was thinking of like a YouTube module so you could like watch videos while you're doing whatever, like brushing your teeth or something like that.
Okay.
All right. Are there any further questions for Noah? If not, I'll turn it back over to Josh.
Thanks, Julia. All right, next up we got Malachi. And Malachi has been extremely persistent throughout the innumerable technical difficulties that we faced during his time at the program. We had lots of trouble interfacing with his Adafruit Pi portal, but all of these challenges has made him extremely resilient and facilitated to his overall understanding of the computer science foundations that's necessary to complete his base project, which is reflected in his modifications, in which he took a lot of initiative and utilized his liberty to pursue the modifications that he wanted, in which he was able to synthesize information from many resources and program the necessary things in order to implement his modification. So I'm extremely proud to present Malachi.
Okay. Hello, my name is Malachi J. I'm a rising senior at Institute for Collaborative Education. And like Josh said, my project was the Pi Portal Weather Station. Pretty much the overall like build of it is like a square box. It comes with two buttons on the top. Goes like a hole for the speaker. And then there's the overall screen. For the screen, pretty much you have the icon, weather icon, which shows what it is now. So it'll be clear skies. And then over on the side it will be the degree weather, so 82 degrees Fahrenheit. At the bottom of the Fahrenheit, you'll have where you are. So for me, it'll be New York, US. And then at the top right, we'll have the date, today's date on year. So it'll be Tuesday, July 24th, 2025. And at over here will be the time. So it'll be 8:26 p.m. Pretty much the PyPortal's functions include that. The two buttons are for the alarm system, which you can set various alarms regarding, regarding lunch, dinner, or certain holidays. And then when the alarm sets off at that time, the speaker is then used to set off that alarm. And you can use the red button to either dismiss, and then the blue one to snooze the PyPortal alarm. And then the main code that was used for this PyPortal were one, the code.py, the settings TOML, the opens weather graphics PMPY, and then the calendar PY. The code PY was the main code used for the overall PyPortal to function correctly, which is all the stuff into one little thing. The settings TOML is where you store like your information like Wi-Fi or any other things. And then for the Opens Weather Graphics Open Weather Graphics PY is where you would get the information from the website. You're fetching data from the Open Weather website to then transfer into your code. So then we can fetch the weather constantly every couple minutes. So then it's shown on the PyPortal. And then the calendar PY is where all your code for the alarms and holidays is shown. And then pretty much I chose this project mainly because I wanted to do something related to the weather since that's also something I like to do is just like look at the weather a lot. Um, and I felt like I like originally when I looked into Bluestamp, I was mainly I'm like interested in civil engineering. But since they also had this and I also interested in the weather, I chose this. And what I learned from Bluestamp engineering and the instructors here are mainly more into the code and how the basics of coding is and how and just engineering in general and how that could also help with like in civil engineering and just engineering in general even though this was mainly focused on mechanical and computer science. And most the challenges I mainly sorry. The challenges I mainly had were mainly like Josh said, it was a lot of coding errors, which then caused the Pi portals to not show anything on it. There was also the SD card wouldn't function properly, so that took a lot of time, which the SD card was a major point for it to work since it contains all the icons. And then the modifications, which I have, it would on the right hand side would be like which is covered, it would be a hole where it's pretty much a sensor that detects light, so it can auto brighten or darken depending on your environment, which was a modification I made. So in order for that to work on this, I'll probably make a hole to make it show. And then the other one was also the icons. So certain icons I did have customized. So for one, I customized like the sun when it rains or any other like cloudy. Um, I haven't done all 50. But yeah, those are really the main things I've done. And yeah.
Awesome. That was a great presentation, Malachi. Thank you for that. Does anybody have any questions that they would like to ask Malachi?
Yeah. Is there a way to like remap the buttons on top of the PyPortal to do another function?
Yeah, there probably is. Like instead of alarms, I could probably set it to do like maybe refresh the page, or I can make it change backgrounds or maybe have it switch to a different place to detect weather from. So instead of New York, maybe I can do California or some other place and just instead.
I have a question for you, Malachi. As your instructor, I had the experience of watching you struggle through a lot of the technical difficulties. So what were some of the techniques that you utilized in order to persist through these challenges?
Um, Pretty much I just didn't want to give up. I also also from like the help of you and the instructors supporting me on to keep moving forward and getting through the issues and resolve them, which really helped me like keep moving forward and not give up easily. So I feel like just trying to figure out things really helped keep moving forward. Yeah.
Hmm. Thank you, Malachi. All right. Next up, we have Neil. And Neil is going to present a mechanically engineering intensive project to you. And I'm extremely proud of the growth that Neil has shown throughout his project. He is my youngest student who has just finished middle school and is now only entering high school. But despite that, his growth is on par with the other older students that I have who are entering their 12th year of public schooling. And with that, I can proudly say that he has had major strides in the three main disciplines of engineering, that being mechanical engineering, electrical engineering, and computer science. And his project is a great integration of all three components. So, Neil, what do you have to share for us?
Um, well, yeah, I'm a rising freshman in Ridge High School, and my project is the 3D robotic arm. As you can see, I'm gonna do a quick demo right here. Um, basically, the Arduino right here is in charge of the coding. This 9-volt battery right here powers the entire thing, and the Arduino is attached to this shield, which connects all the wires from the servos to the controller. And basically, the servos can basically move it left, right, up and down. And this one right here can open and close the clock. Right there. And now I'll do a quick demonstration. If I move this left joystick this way, it makes it go up. And if I make it go that way, it makes it go down. And then if I move it forward, it makes it go forward as well as backward. Now for the clock, if I do this one, can open it and close it. If I move it that way. And then, that's it for the demo. And the reason I joined Bluestamp Engineering is to get more mechanical and electrical, as well as computer science, experience, and to get more overall independence in the engineering field. Because in the engineering classes I took in middle school, it was more teacher dependent, and I had to rely on my teacher for most of my knowledge. But I kind of like the way Blue Stamp kind of teaches me more because it was more independent. I felt like I moved quicker and faster, and I like learning more independently, anyways. And yeah, that's it.
Awesome. Thank you so much, Neil. That was once again a great presentation. Does anybody have any questions that they'd like to ask Neil?
How do you think you could modify this robotic arm to make it like more suitable for industrial applications?
Well, I would say just to make it stronger overall, as well as bigger to carry more loads. I would say to also make sure it's like not glitchy, as you've seen before. It was kind of jittering a bit. Um, yeah.
Neil, you mentioned how you wanted to enter Blue Stamps because you wanted a more hands-on experience than what your middle school could provide. So, what are some of the new perspectives or insights that you've gained now that you've had a more hands-on experience with engineering?
Um, what I would say is that it's easier than it looks, to be honest. Like beforehand, I thought like it's kind of a nice experience to create something with your own hands. And at first, I thought it was like a huge task. It was like impossible to make. But now that I made it, um, I thought it was actually quite easy. So yeah.
Awesome. Yeah, it's great to have that mentality, you know. It's like the quote of the day that we had a couple of days ago, you know. Everything seems hard until you complete it and you look back and it was a lot easier than you expected it to be. Thank you. Does anyone else have any other questions? Okay. Well, next up we have Harini. Now, similar to Roger, she pursued an audio-based electrical engineering project, and she demonstrated um, high levels of understanding of really complex topics like the fast Fourier transform, which is a core pillar of electrical engineering. And despite her younger age compared to the other students, she has made phenomenal strides utilizing her background in computer science to independently code up a TFT screen that she will now demonstrate to you. So, Harini.
Thank you. Hi, my name is Harini. I'm from West High School and I'm an incoming freshman. My project is the audio visualizer using an Arduino and a 1.4-inch TFT screen. So here's the demonstration. I'll be demoing how it reacts to my voice and to sound. So if I speak, hello, hello, oh, and then if I play a sound, so that sound, I don't think you could have heard it. I forgot to do something. So that sound was, uh, it was getting louder as it moved on. So it was going from quiet to loud. So you could see that reflected in the screen because the bars got taller as the sound got louder. Okay. So how it works is that the microphone detects sound signal, and that input is taken in by the fast Fourier transform, which breaks it into 64 small pieces called bins. Each bin has a number that shows how strong a part of that sound is. We use the first 32 bins, so you could say that each bin controls a bar on the screen. Bigger numbers mean louder sound in that area, so the bar is taller. That's how the visualizer knows how tall to make each bar. The first error that I ran into was that my screen wasn't refreshing. The bars froze in place and didn't update with new incoming sound. The solution I had to go to was instead of drawing rectangles for each bar, which was slow, I drew two vertical lines instead. After doing that, the issue of the bars being drawn faster was solved, but they still weren't going away. I fixed that by drawing black lines to erase the old bars before drawing new ones. That made it way smoother because the bars were coming in, going away, and coming in again. The other challenge I faced was that I switched from an LED matrix to a TFT screen in the middle of my project. I had to learn which pins to connect the Arduino to the TFT screen to because the connections from the LED matrix to the Arduino were different from the TFT screen to the Arduino. I also had to change I had to change my original code to make the TFT screen work properly without having the TFT screen physically, which was difficult, but luckily for me, the code worked fine. The only debugging I had to do was the previous frozen screen error. I chose this project because I liked coding and music. This project let me combine both interests in a way where I could see the result physically while listening to music. This also leads into why I joined Bluestamp. I could already code on a screen and see the result in a website or an app, but in Bluestamp I was able to see the result physically and I was able to work with new hardware and face new challenges. Thank you.
That's awesome, Harini. Thank you so much for sharing all of that. Does anybody have any questions that they'd like to ask Harini? Okay, well, I have a question for you. So you mentioned how you wanted to pursue this project because you have a shared passion in both music and engineering. So after doing this project and learning about topics like the fast Fourier transform and seeing audio on a visualizer like the one that you built, how do you think your perspective on music or engineering has altered?
My perspective on music has definitely changed a lot more for the technical side because before doing this project, I definitely thought of like noises or sounds or lyrics before when I thought of audio. But now that when I think of audio, I specifically think of like frequencies and bins and the fast Fourier transform. So a much more technical understanding.
That's amazing. And I'm really proud of the growth that you've shown during the past 3 weeks. Does anybody else have any other questions? Okay. Well, finally, last but certainly not least, we have Josh. And Josh is an incredibly dedicated student. He is at Innovation Lab each and every day, and it shows in his project. He utilizes all the resources that we've given him to kind of to stretch out his wings and be able to be autonomous in the modifications that he builds. And I'm extremely proud to present Josh now.
Thank you, Josh, for the introduction. Hi, my name is Josh, and I'm a rising senior at Dublin High, Dublin, California. And my project is a gesture-controlled robotic car using two Arduino microcontrollers, and they're connected via Bluetooth modules. So how it works is, first of all, on the controller, there's an accelerometer, which basically it reads raw data from how much you tilt it, and it sends that data to the Arduino Nano, which is running a program that converts that data into gestures, like forward, back, left, and right. And those gestures are sent to this Bluetooth module up here, which is connected to another identical Bluetooth module in the Arduino to the Arduino Uno on the car. And the Arduino Uno takes that Bluetooth gesture and converts it into a motor command. So it tells the motors which way to go. So if I say forward, it'll turn the motors forward. Now, one challenge I ran into during this project was that the power supplies would overheat due to the motors drawing too much current. So what I instead did was use two 9-volt batteries, one to power the rear motors and one to power the front motors, and that distributed it evenly and made sure that it wouldn't overload the batteries. The biggest lesson that I learned during this project was to pay attention to detail while breadboarding. Like, I can't even remember the amount of times that I had to send a picture of my wiring to Josh on Discord to help like figure it out. And I made two modifications to my project. The first of which you can very clearly see is this platform up here, and it just carries any payloads, such as this little BB-8 figurine. I can put it on and it'll still work. And the second modification that I had was this ultrasonic sensor, which automatically stops when it reaches an obstacle. So now let me show you a little demo. If I point it this way, as you can see, there's a wall right here. Now let's see. I will tilt this forward, and it stops because there's a wall. I can move it back, forward, and it stops automatically. And I can also move it right, left, and making sure it doesn't fall down, back and forward, and it'll stop because there's a wall in the way. One second. Okay. Now, I picked this project because I love cars. I'm really passionate about them. And I want to go into the mechanical and automotive engineering fields. And I definitely thought that this project would be a beneficial experience for me, and it definitely was. It's also really fascinating that you can control a whole like robotic car just with movements from your wrist. And that was like that really hooked me onto the project. Thank you.
Awesome. Yeah. That was such a great presentation and a really cool demonstration of your project, Josh. Does anybody have any questions for him?
How do you think your project can affect like someone's daily life?
So actually, you can, so you know how I showed you this payload platform up here? You can actually modify it to hold anything like food. You can make like a food safe container up there and make sure that like a bowl of pasta or something doesn't fall down from it. And suppose like my mom is cooking in the kitchen and she's making that pasta and suppose the gas is still on, she can't be actively going and giving me a plate of pasta. She has to like she can easily just put it on this robot and the robot can deliver it to me at the dining table. And I think that would just be a more efficient use of time.
Anyone else?
Um, what other modifications do you think you can make to your project to make it like better or function? Yeah, like what do you think some modifications you can do to further improve your project? Yeah.
So one modification another line was using a project such as Neil's robotic arm, which could basically pick up an object off the floor and lift it and place it onto the platform, much like a garbage truck, like how they pick up dumpsters and they throw it into the back. except this time you can pick up any object and put it onto the platform, and that would make it even more versatile.
Awesome, yeah. I've got a question for you now, Josh. You mentioned how you wanted to enter the automotive engineering industry, right? And clearly your project, which was a car, reflected that. So how do you think completing this project maybe gave you more insight about automotive engineering?
Right. So, as we all know, the future of cars is electric, and this car exhibits, like, although it's not the exact same as a real electric car, it exhibits a lot of the same properties, such as having a distance sensor in front, as we know of like adaptive cruise control and distance sensor in Teslas, like we've seen. And it also has electric motors, which have programs on them. And basically, we don't have to use the steering wheel in the future. We can use much more natural movements, such as a gesture from your wrist, for example, which could move the car forward and backward. And it's just more convenient for the driver.
Awesome, yeah. Does anyone else have any other questions? I've got a follow-up question, Josh.
Okay.
So, as your instructor, I was there to witness like the journey that you had, and you seem to encounter a lot of issues in terms of like wiring or power delivery. So, how did you kind of overcome those issues?
So actually, you and Everest really helped me through that a lot. You guys gave me some important strategies, such as like stepping back, breaking every problem down into tiny little pieces, and focusing on the details. And I think those like strategies, like following those strategies, really helped me because
Mhm.
it made sure that I wouldn't get overwhelmed by the big problem. I would try to pinpoint the problem by looking at every small detail.
Awesome, yeah. I think that's a really great answer that you just provided. Does anyone else have any other questions? Okay, well, that is all the students in this breakout room. We are a little bit ahead of schedule. So, are there any questions that you'd like to ask any of the students, me, or Everest, the lead instructor?
Since we have finished out the room, I'm going to go ahead and stop the recording just in case any of you do wish to speak out. So recording